It should be okay then for you. Good job, good job. What time have you to submit at? 1 o'clock, okay. Into Sylvia's office? In this room? Oh, so after this class? Ah. Okay. So I'm picturing like a group of my students printing now in, or something like this, right? Yeah, okay. Right. Okay, so what we're having a look at now, probability tables. So, often, to be more realistic, when we're looking at probabilities, different events have different outcomes or different likelihoods. Like, let's have an example here. So suppose I want to have a look at probability of the different grades you'll get. Okay? So the X here are the outcomes. So you could get an A star, an A, a B, a C, a D, an E, a U. What the heck happened to you, Mo? What did I just say a minute ago?
Had a disaster in the morning. The printer this morning.
Okay. Right, so we can represent the different outcomes with different probabilities. Come on, hurry up. What was I saying? Oh yeah, so we can represent the different outcomes with different probabilities. So for example, perhaps we'll say that there's a 10% chance of getting an A star and a 10% chance of getting a B. And maybe there's a 20% chance of getting another A, a 20% chance of getting a B, 10% getting, no, maybe 20% of getting a C, and then 0.1 for a D, 0.1 for an E, and 0.1 for a U. So one thing we need to make sure is that this adds up to 1. Oh, it doesn't, sorry. So I'll make this A actually a 0.2 as well. So 0.1, 0.2, 0.2, 0.2, 0.1, 0.1, 0.1. So the total probability in these tables, it must add up to 1. You can't have it any other way other than 1. And this is actually a common way to represent outcomes for X. It's a very convenient way to do it. It works very well when there's not many outcomes for X. You can represent everything quite clearly here. So you can easily answer questions like, what's the probability the student will get an A? So what would that be? What would that be? 1%. Of an A? 2%. 20%. 20%. Yeah? Is this okay? You seem a little bit confused. What is the probability the student will get an A star? 10%, yeah. Okay. Let me give you one to try. What's the probability the student will get an A star or an A? 0.3. Good, okay. What's the probability the student will fail? Yeah, and fail means less than 40%. So it'll be 0.2 because these two grades. Yeah. Yeah? Are we getting the idea for this? No? Well, technically no, but to be honest, there's not many universities that will take an E grade, so it's effectively failing. You know, but I suppose you're right. Technically, for NCUK, a U is a fail. Yeah, but I mean, there's in theory and in practice, So if in practice nobody gives you a placement on an E, then you might as well call it. Some places do though. Okay. Yeah, but I mean, technically or in real life? Which would you like to know? No, don't worry. In the exam they'll make it clear. So they'll say in the question, failing grades are E or less, or something like that. So in my question, I'll call these two failing grades in my question. Okay. Right. Now, what about if I said something like the probability the student not getting an A star? Well, you could add up all of these numbers, which are not A stars, or a quick way to do it is 1 minus the probability of getting an A star, which in this case would be 0.9 then. Yeah? Okay, so let's see. Let's do another one here. Let's say probability that they get a B or better. Okay, so what would that be? Yeah, it'd be 0.2, 0.2, and 0.1 then, so that would be 0.5. Okay, right, so that was kind of a simple enough question to just get us warmed up. I'll just give you a minute to write these examples down, and then we'll have a look at another one. Continue. Amjad, put the phone away.
B or better doesn't include B.
What do you think? Yes or no?
Yes.
It includes B. Anyone else with you?
No.
Okay. This is quite late. You're the last one. Anybody else after you, I'm not letting in. Oh no, not there.
Oh.
Yeah. There's fine.
I love this ball.
Oh yeah, so I don't forget. Yeah, he's not allowed to sit there anymore.
Why is that?
We'll see. It's a program. We'll see how you develop on the program. What was I saying? Oh yeah, so I don't forget to tell you, I'm just going to be a little bit stricter with timekeeping after the break. So after the midterm break. So after the midterm break, I'll just be a little bit stricter with the timekeeping. So people who are 15 minutes late, not coming in, and what will I mark as the attendance? Yeah, I need, if you're not here by 5 minutes, I'm not taking the attendance for you. Okay? So I just want to be a little bit stricter with the time. So, of course, if you're late because you have a reason, just send me an email, that's fine, okay? But we just want to be a little bit stricter. I understand that there's stuff going on today.
Do you actually check your email?
I do. I just might not reply. That's different. I check, but not necessarily reply. Okay. Can I scroll down? Yeah. All right. Right. Now, I'll give you a small one to try. We'll say, what will we look at? Maybe we have a die, and it's not a balanced die, so it's loaded, we say. 1, 2, 3, 4, 5. Oh, I have 6. 1, 2, 3, 4, 5. Okay, so it's a little bit too big. All right. So let's say we have 1, 2, 3, 4, 5, 6, and I tell you that this is a point 2, 0.2. That's a 0.1. That's an X, and that's a Y. Okay. And this is a die. And we're missing the probability of getting a 5, and we're missing the probability of getting a 6. And I also tell you for this die, the probability of getting an even number is equal to 0.45. I've actually given you enough information to work out what the X and the Y must be. Okay? I'll give you a minute. I think a lot of you should be able to figure this out. See if you can figure out the X and the Y, what they must be. Yeah. What's the X and the Y?
Is it possible in the exam to get this question related to dice and cards?
Oh yeah.
Or is it just something you
No, I can't see. No, in fact, I've seen the dice as a question a couple of times.
This dice is complex.
say the total probability is 1?
Yes. You would know that if you were here at the start.
Sorry.
Right. For which? Yeah, let's have a look. So the probability of an even number is 0.2 plus 0.1 plus y, and that should equal 0.45. So that gives us the y is 0.15. And also if you add them all up, 0.2 plus 0.2 plus 0.2 plus 0.1 plus x plus 0.15, that should equal 1. And what did the x work out here as? 0.15 as well, was it? Okay, so that's an exam type of question. You know, the previous one was a little bit too easy. Yeah.
How could a dice have such interesting properties?
Well, maybe it's not a real dice. Maybe it's like a digital dice. You know, some casino machine or something. Or perhaps the dice really is fair, but the student has misjudged the probabilities. I don't know. Can I scroll down? Yeah. Now, there's no reason that the table has to be just a row. It could actually be a row and a column. So, for example, you could have something like this. You have two dice. And you could have a 1. Now, you don't have to write the whole thing down, just enough to get the idea. You could get a 1 and a 1, a 1 and a 2, etc., 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 all the way up to a 1 and a 6. And likewise here, you could get a... no, I've done something wrong there, sorry. Sorry, that's wrong. You have two dice, and this is the first one, and this is the second one. So on the first one, you could get a 1, 2, a 3, a 4, a 5, or a 6. And on the second one, you can get a 1, a 2, a 3, a 4, a 5, and a 6. And in the table here are the probabilities. So here, a 1, 1 would be what? What's the probability to get a 1 and a 1? 1 over 36. The probability to get a 1 and a 2? 1 over 36. In fact, all of these are 1 over 36. I just want to show you that your probabilities tables could actually have, you know, it could be 2. Could be one outcome and another outcome. There's no reason that it has to be just one table here. Have you done your genetics in biology yet? No. Coming up, okay. So I know part of the genetics is a calculation of probabilities
Yeah.
for the different combinations of dominant and recessive genes. Yeah, yeah, phenotypes. Yeah, yeah. Okay, can I scroll down? Yeah. Okay. Right. Let's see now. Let's do. Have you done any probabilities in biology? Nothing. Any genetics? No.
We did some
Base?
like genome sequencing stuff.
Yeah. Probability of the ratio of frequency of protein certain codons.
Ah, did you have to calculate it or were you given it?
Count.
You have to count.
Manually count, yeah.
Yeah, okay. That's not challenging. I think you know how to count. Have you done? Yeah. You need to go down and under. Or you need to get to that room. Yeah, yeah, down and under. Okay. Have you done genetics? So, like, have you done dominant and recessive? You haven't done it yet.
Just like half the class knows.
Right. And what was the example, Angela, you were saying with your frequency one? What did you have to count? So, like, what was the data? Oh, just letters, was it?
The actual codons from RNA, and they have a table that says which these codons, what amino acids.
Oh, you have it. Wonderful. I wonder if we can put it into a probability table.
Second page.
We had second page, we had to count and then figure out which one was it from.
We have 4 codons for each.
Ah, yeah, okay. So this is kind of like a probability table because with each value here is a number,
Yeah.
but it's a frequency rather than a probability.
Yeah.
Okay. Yeah.
Each
That's-
amino acid is like, it's not the same amount. Some of them have 6 codons, some of them have 3 codons, some of them have 1 codon. So it's random.
Mm.
It's redundant but not ambiguous.
Also boring. Okay. No, I won't do that. That's too boring for me. Sorry. Too boring.
I think I would agree with you because the state of my thing.
Yes. Okay. Okay. Let's have a look at one here. I'll give you a harder one now. Okay? So let's say we again we're rolling a die, and this time it's fair. So each outcome is equally likely. Okay? So I only care about, when I roll the die, I only care about getting a 6. If I get a 6, I win. If I don't get a 6, I lose. So what's the probability that I win here? If I roll it, 1 over 6 then. And the probability that I lose? 5 over 6. Okay, so what I want you to do is to make a table. For n. And n is the number of times I have to roll so that I get a 6. So for example, 0. What's the probability that I'll get a 6, that I win, if I roll 0? It has to be 0. 1. What's the probability that I roll once and I get a 6? 1 over 6. Now, the next one, let me just explain, listen carefully. 2 here. That's the that's the probability that I win on my second go. So in other words, lose and then win. So the n here represents how many tries I need to win. So what would that be? It would be lose followed by win. So that's 5 over 6 times 1 over 6. So that's 5 over 36. Okay. 3. So that would be lose, lose, and win. In other words, I need 3 goes to win. Okay? Yeah, so you get the idea here. So I want you to finish this table here. Yeah, please, yeah. Okay, I think you have this table done. So what's the next one here? 125. Okay, that's I can't actually fit that. Over 216. The next one? Ah, yeah. Over 1296. The next one? 7776. Probability it takes you 6 goes to win. What's that?
3125 over 466.
466. 56. So you all understand, of course, that this table actually extends out to infinity because, you know, in theory, it could take you any number of tries to get your winning 6. But you realise that as we move out, it's getting less and less likely we'll have one of those situations. Yeah. So.
Does it ever hit 0?
No. Very good. Very good. I want you to tell me what's the probability. It'll take you 6 or more goes. Now there's 2 ways to calculate this. Okay? Obviously you don't do infinite calculations here. Okay? There's 2 ways you can think about calculating this. I want you to try and calculate, and I want to see which way people think about calculating this. So 6 or more goes. So I'll leave a space here. There's 2 ways to do it. You got an answer? Yeah. Did you calculate this? Yeah. Alright. Let's have a look now. Guys, yeah, have a look. So, first way you could do this is 1 minus the probability of not getting this. Which is 1 minus, and then you add up not. So that would be 0 to, where would I stop? 5, yeah. So it's 0 plus 1 over 6 plus 5 over 36, etc. And you stop at 625 over 7776. Who bashed that out? You got an answer? 3125 over 7776. But I said there was a second way to do this. You can actually calculate this 6 or more. Is the 6, which is 3125 3125 over 46656 plus, and you could add them all up. Now, how could we do this? Yungpeng actually spotted this. If you look at the numbers here, they actually form a geometric progression where the A is this guy and the OR is 5 over 6. So you could use your formula A over 1 minus OR. So that would be your 3125 over 46656 over 1 minus 5 over 6. And that would be the same answer, 3125 over 7776. Yeah? I don't know. Did anybody think about it that way? No. Last thing here for this question is I want you to confirm, we'll do this together, confirm that the total probability is 1. So that would be 0 plus 1 over 6 plus 5 over 36, etc., etc., etc. Now we don't really care about the 0 here. So again, remembering that this is a geometric, what can I simplify this to? Equals A over 1 minus R. In this example, what's the A? 1 over 6. And the OR is? Yes. So that would be 1 over 6 over 1 over 6, which is 1. So even if the table is infinite, it still all adds up to 1. Okay. So that's in the final exam, you see, they're testing you on both semester 1 and semester 2. So sometimes they might like to merge 2 chapters together. So this would be a good example of merging this lesson with the geometric lesson. You know? They don't merge the chapters too often, but you know, sometimes they might throw in a question where you would need something from semester 1 and semester 2 to answer it together. Exactly like what I did here.
This is a section B question.
I'd say this would be a section B question. If they're merging 2 topics together. The section A tends to be a little bit more just straight to the point. Yeah. Did you write this one down? Yeah. Okay, so look, this is not really a difficult, that question I just did there is kind of the hardest I could imagine it possibly being. So it's not a particularly difficult lesson. So I don't want to give this too much more time than it needs. So just try these for 5 minutes. And then we'll go on to the next lesson, which is a little bit more difficult, but not too much more. So just, I'd say it wouldn't take you long to do question 1 and 2. So you should actually get number 1 done in 5 minutes for sure. And even number 2 maybe as well. So can you try those now? Question 1 and 2, just give them a go.